Hello, my name is Jason Peterson. It is April 27th. This is for EDU 255, and today's topic is functions and their graphical representations. This is found in the Common Core State Standards for the state of Michigan under the functions section, which is on page 68 through 71. And this content is typically first introduced in an Algebra 1 class and is used in every single math class after it pretty much, so kind of important. All right, let's begin. Good afternoon, class. Welcome to third hour. And today we're going to be continuing our work with graphings, but today we're going to add something new to it, something called functions. So let's think back to last week, where we graphed things in the coordinate plane system. For example, we would draw our coordinate plane, x and y, and we would graph things like the line y equals x, which would look like that, or the line y equals x squared, which would look something like that. But that's what we did last week. And today we're going to add something new to it, something called functions. So let's get into that. But before we get into that, a little example for you guys. So, say I'm hungry and I want a snack. Well, I'm gonna walk down to the nearest vending machine. And I see that I want Sour Patch Kids. Sour Patch Kids. And to get these Sour Patch Kids, I have to hit a button. And I click the A1 button. And it gives me Sour Patch Kids, just like I wanted. That means I had one input, I inputted A1, and it gave me out my Sour Patch Kids, which is what I wanted. That is sort of what the baseline of a function is. It is, we take our input and we get a unique output. Because it wouldn't be a very good vending machine if I clicked A1 and it gave me something I didn't want, like Oreos or something. Wouldn't be a very good vending machine. So that's just the sort of basis for a function. And today we're going to go over what is a function, how do we represent these functions in math, and why it's useful in the grand scheme of things and in real life. So let's begin. Get rid of that. All right. So the first thing we are going to go over is a basic definition of a function. So let's write that down. A definition. So a function is a relationship between two variables an input and an output, where each input has exactly one output. So let's put this back in the context of our vending machine example. We have our input, which would be A1, C12, whatever we click, and it gives us a unique output, which is our snack we wanted, like Sour Patch Kids, etc. Hence, a vending machine would be a good example of a function. But let's unpack this definition a bit further. So we have our input. And what is this input? Well, let's write it down over here. Input. So our input is typically called the independent variable. Let's write that down. Independent variable. Independent variable. And typically we call the independent variable x. Now we can call the independent variable whatever we want, whatever variable we want. We could call it t, we could call it s, we could call it c. It doesn't really matter too much, but typically in math we call it x because that's what we've agreed upon as our independent variables or our inputs. Let's move on to our outputs. So an output, and we call the output our dependent variable. So dependent variable. And typically our dependent variable is denoted y. Let's call that y. And again, it is just a variable, so we could call it whatever we wanted, but conventions and typical math standards call it y. And for this course, I will call it x and y as our independent variables and dependent variables likewise. So that is our sort of a formal definition of a function. It is a relationship between two variables, an input and an output, where each input has a unique output. That is what a function is, and that is our base definition. So let's move into how do we represent these functions in math. And there's a couple ways we could do it. One way is we could draw a diagram, label our x, our inputs, and our y's, our outputs, and put numbers in here. 1, 2, 3, 4, 5, 6, 7, 8, and draw arrows to represent mapping between our inputs and our outputs. So an input of 1 maps to an output of 5, an input of 2 goes to 6, 3 to 7, and 4 to 8, and so on. And that would be a function, since each input has exactly one output. But that's not really the main way we like to represent functions. It's a useful tool to keep in mind, but it won't be the sole focus of our function unit here. So let's get rid of that. The real way we like to represent functions is with graphs. So think back to last week again, where we were graphing equations in the coordinate plane system, and we're going to do something similar here. So let's draw our x and y axis, x and y axis. Let's change colors. So we have our x and y axis here, and let's write our function as f of x equals 2x plus 1. So the main difference between last week and now is I wrote it as f of x equals 2x plus 1. And what does that mean? So that f of x stands for function of x. Let's write that down. Function of x. That stands for function of x. And typically in math, the real formal way to write it would be y equals f of x equals 2x plus 1. That just means y is equal to f of a function of x, which is equal to 2x plus 1. It means pretty much the same thing as just y equals 2x plus 1, but it is just a more formal way of writing it down, and it clarifies things even further when you get to higher math classes. So for consistency's sake in this course, we're going to be writing down as f of x equals 2x plus 1. So we have f of x equals 2x plus 1, and let's graph it. So 2x plus 1 will look something like that, and there's a graph. But how can we tell if this graph is a function? The way we do that is something called the vertical line test. So the vertical line test means you take a vertical line, I'll use the marker in this case, and we put it on a graph. And we move it from left to right, and we see if our vertical line passes 2 points on the graph. So in this case, I put my vertical line on the graph and move it through it. It only ever touches one place on the graph at any given time. So that means it's a function. We're good. However, there are some things that aren't functions. And let's take a look at an example of one of those. So let's get rid of our 2x plus 1. There we go. Got rid of that. And let's graph something new. Let's say a circle. Let's do x squared plus y squared equals 1. And that is a circle with a radius of 1. So let's draw that right here in our xy plane. That's 1 right there. Here's a circle. And is it a function? Well, we have a test to check, the vertical line test. So take my marker, we're going to put it on a graph, and we're going to slide it over, and we run into a problem pretty quickly. So at this point right here, we have a vertical line. I'm going to draw the marker in. We'll say that this line's our marker right there. And there's a problem. We have a point right here and a point right here. This means for the input of, let's say that's probably right around -1/2. For the input of a -1/2, there are 2 outputs, which breaks our definition of each input having a unique output. Thus, our circle here is not a function, since it does not pass the vertical line test, and our outputs are not unique. So that's our main way of testing if seeing if a graph is a function and so forth, which is useful. But let's move on a bit. So, why should we use functions? Why are these things useful, and where do they help us in real life? So, again, think back to that vending machine example I put down. That is a good example of a function in real life. Because if I type A1 into a vending machine, it had better give me what I want, which is Sour Patch Kids, or else it wouldn't be a very good vending machine. So, a vending machine maps inputs to unique outputs, which is a function, and it's a good use of it. So another such example in real life would be at the airport. So at the airport, and you have one runway, and you need planes to land. So say at 2 o'clock, you're scheduling planes to land. You want one plane to land at one time, or if there's going to be problems, which is a function, because your input at 2 o'clock has one output, or your plane landing. That's not a good use of functions. And the last major place functions are used is in your science classes, such as physics, or something like that, or chemistry. In these classes, usually functions are used to represent real life things, like motion of an object. Like if I drop this marker right here, that can be a graph of a function in physics, where at each input, which would be the time of its falling, would have one output, which would be the place where it's landing. So it would look something like this. You would have time, and you would have your placement, and you would see the marker would fall. And each input has a unique output. So that's another good example of using functions in other places in real life. And also functions have not our use, but it's in computer science. Functions come up a lot when you're programming things, doing coding stuff. But I'm not a very good coder, so if you have more questions about that, go talk to the computer science teacher. He will let you know. But that sort of wraps up our lesson. Today we looked at functions, we saw what they are, we saw how to represent our functions, and we saw why functions are useful. That concludes our lesson today. Our homework is posted. It is page 79, 3 through 12. And those are going to be due tomorrow. And they're all to work with functions. So try out some of the knowledge we learned today. And if you have any questions, ask away. Thank you.